Hello, and today we're going to get started with our initial project planning. So, if we go to our acceptance criteria list, what we are going to do is label each acceptance criteria as its own ID. So we will be referencing this throughout the project. So to get started, we're going to treat this initially like a command line application app, and then turn this into a HTTP proxy app. So the first thing we can do, if we look at AC4, is allow the administrative setting of rate limit policies per domain. So that is a good first thing to start with. Oh, don't want to do that. And if we go back here, we're going to start with our Scrum planning. So go to projects, create project. This will be our project board for planning out the task we're going to complete. So we're just going to call this planning board. And we are going to want for this to be an automated Kanban board. A great project. And we're going to clean some of these up. It's fine. That's fine. So, our first issue to get started is going to look at creating a command to allow the setting of rate limit policies per domain. So we're going to create a new ticket. So in the description, I'm going to mention C4. All right. So what we want to do is allow administrate. So you want administrative users to set the rate limit for a given domain. So then, since we're the only ones on this project, we're just going to give us this, and we're going to attach it to the planning board. I'm going to create issue. And if we go to the project board, we should see that it's in our to-do. So something we're going to want to add to this ticket is we're going to want to add testing specifications. So right now we're going to not write any code for the test. What we are going to write is a high-level language. So given a user is an administrative command line, or we can make this look a little cleaner. Command line user, when the user sets the rate for domain com2, and exact details here don't matter. We're probably going to change it when we go to write our code. Just put it down a number and retroactively change it when we need to. Then the rate limit for domain. The example should be 50. So it looks a bit silly to say when the user sets the rate limit for a domain to say 50, then the rate limit for that domain should be 50. This seems like a tautology. Um, and there may be some tests that generally are this kind of way. There are some tests where there can be a lot of subtlety that's hidden that isn't immediately clear. But what we're doing is we're setting the expectation that when we go to write test to verify the correctness of the application, when you take some action, the requirement is that the expected result of that action has been taken. So this would catch, say, the use case where setting the value failed, or setting the value, if it was asynchronous, maybe when we go check the value, if behind the scenes the value hasn't been set, it's in the process of being set, we get back a bad result, that would indicate a failure scenario. So as silly as it is to be this simple, it is actually important. So we'll just comment that. And in the future, we can always go back and edit it with better details. Particularly 50 is a made up number. We probably should say 50 per hour, 50 per minute, 50 per second. That's a design detail. We haven't gotten into designing that part of the application yet. And we'll eventually like parameterize this anyways, so it's not that big of a deal. So now if we go back to our application, we can go and say add a new folder. So nothing, anything, and then we'll just call this features. And then we'll go add that test in here. So there is, it's a language called Cucumber or Gherkin. For now, we're just going to call this anything. So for this feature, this is going to be mostly for AC4, but rate limit set. And we'll change the name of this later. Go in and copy this. Go back and paste this. And you're not up high. You should be a feature. And all right. Then I believe this is a scenario, so we'll worry about that later. So the nice thing about this kind of testing is that it makes it very easy for project managers or other developers or not semi-technical users to write these tests for the features that they request. So it's a lot clearer about what the expectation should be. But next, we're going to want to lay out our general source structure for our code. So we're going to go create a Python package, and have to try that again. Just call this source. And then what we're going to want to do is create two folders. So CLI.py, or no, this is a directory. So CLI will be our command line specific stuff. And then next is going to be our controller. So we're going to treat this as a simple MVC, model view controller application. And we'll start with the logic in our controller. We'll expose that logic in the command line interface, which then we can test. So the next thing we're going to want to do before we write any code is actually set up our Python environment. So if we go over to here, and we're going to have to add we're going to create a new environment. And I believe I'm currently on Python 3.8. You'll want to inherit the basic site packages. And we'll see how that works. Alright. And to check, we'll run our console. And it's running. So then next, we're going to want to specify our requirements. So just call that and I believe the first library we're going to want to play with is something called click. Go down. So do Python version. Just make sure we're not on 2. So that is the default version for macOS, I believe. We're going to do Python pim pip install click. And that should have installed it. Now, I know there's a bar that says install libraries. I try to avoid using the IDE for installations because I've run into some issues with that in the past. I'm not saying that you shouldn't, but in general, command line pip install works just fine. So the next thing we're going to want to create is the source file for our rate limit command. Go to Python file. I'm going to call this rate limit. We're going to give it some initial documentation. Line of right. So our first command is going to be set rate limit. We're going to want to have 2 arguments. So first is the domain, which we're going to define as a string for now. And then next is the limit, which we're going to define as a float. Then what this function will do is it'll set the rate limit for a given domain. So for the domain, limit in requests per, just go for a second for now. Now let's see how we're going to use click to set this up as a command line argument. If we go back, I already have the documentation page for that. Just going to do click.command. And that's going to be yes. And the 2 arguments we're going to want to have are domain and we're not using options because those are named. These are just arguments. I think is it arg equals expect 1 limit arg equals 1. And that should be our initial command, which right now currently doesn't do anything. So next we're going to want to put this in a group. So to do that, do give it a name called rate limit. Then we're just going to define a dummy function that doesn't do anything. And then we're going to do, now what we can do is say rate limit, pass in the argument set. So if we do the word rate limit and then set, when we invoke this script, which we can do by checking here, we can call it. And just for now, we're just going to print out setting rate limit. And now we invoke this. Then source.cli rate limit. See, it's going to give us some issues. So then we're going to say set, and it's going to want an argument. The other thing is it's not using the rate limit name because it needs a further higher root. So that's easy to fix. We just go to click.group and we'll give it a no name. We can do say root. So if we have many commands, this helps us keep organized. Then to do this, just call root. Now we can say rate limit set, and we just give it a domain and a limit. It'll call with no errors. So that's nice. Now this is currently a little painful to have to type all this out. And as we add more command line scripts and functions, we don't want to have to go search for every little file. So it's nice if we had one file that handled all that. So to do that, what we're going to do is create a nice little helper script. Let's run .py. And what run.py is going to do is effectively handle all the CLIs. It's the entry point to all the CLI. So what we can do is say we're going to move root over to here. And give that space. And this file should not be really running anything because it should not be invoked as main. Now we want root to be passed into here. So one way we can do that is say define register. So the two ways we can do this is we can define register in here, and root will be the grouping that's passed from within run. So then what we can do is move all these here. And this says registers commands. If we do that and we go up here, so we say import source.cli.rate_limit. You can say source.cli.rate_limit.register root. Now, this is a little painful because for one, all of our functions in here are no longer top level. And as well, we have to remember anytime we have to add anything, not only just to import it, but also to register it manually. But this way we can at least have one common variable without having to have every single file kind of be its own standalone script. And now we can see if we try to run this, hopefully there's no errors. Run.py, rate limit, and then set. It might not like, it might just be, oh, doesn't need a pi. Actually, it might not like that it's in the .py. Oh, I put it in source. That's easy fix. I want you to be refactored and move up one level. Move you up here. Let's try that again. Then just pass in the domain. Rate limit. And that sets it. Now this currently still does not meet our acceptance criteria because no value is internally set. That's no matter. So if we go up to here, make sure this is all saved. So next, we're going to want to have some kind of actual logic that implements this set rate limit. So go into controller, create another file. This will be the file that manages that. So we bring it over to here. Say set rate limit. Define for managing rate limits. So we're going to take 2 arguments. So sets domain. So we're going to set the internal rate limit of a domain. So first, we're going to want to assert is instance domain string, and we want to raise value errors if the passed arguments are not the actual values we're looking for. Raise value error. Main must be a string. And second, if not is instance limit float raise value error limit must be numeric. And in fact, we could possibly get a limit as a integer as well. So one thing we can do is say all right. We go back here. So we take the value of the limit, or the type of the limit, and we say it must be either an integer or a float. And if it's not, then raise the value error. Next, what we're going to want to do is make sure that the limit is a sane value. So if the limit is less than 0, raise value error, limit must be 0 or positive. Finally, do param domain. It's the name of the domain. And param limit and requests. And for now, I think I'm going to actually do changes to per hour. The reason being is we might get limits in either per hour, per minute, or per second. And I think starting for per hour would be the easier one to deal with first. Now, if we want to invoke our logic, we can say import source.cli.controller and .rate limit. Oh, not CLI. Just pay attention. And then what we're going to want to do is say source.controller rate limits, and then we just pass in the arguments. Now, set rate limit. Now this actually might fail because I don't know if limit is passed in as a string or as a number. We are going to see. Yep, it is passed in as a string. So, what I'm going to do is say try limits equals float limit. Then we're going to try to coerce limit to be a float, and if not, then we're just going to say print. And we're going to have better logging in our command line applications, but for now, we're not going to we're not going to assert any kind of special logging. So we can say limit argument must be numerical value. You can see if that works. And then if we try, say, string, actually should also probably return. Yep, there we go. So we don't get that nasty stack trace. And ideally what we would want to do is capture exceptions at the tallest, highest layer, so we don't get a big old stack trace when we don't expect it. But we also don't want to throw away the stack trace when we get an unexpected stack trace, unexpected error. So that's going to require some future development, but for now, this will do good. And finally, we want to test the case where if we pass in a negative number. Oh, that's interesting. I believe that click might be interpreting that as a possible argument. So let's do this. Interesting. So we cannot easily set negative arguments. Huh, I didn't know that. If we give it no argument, so that appears to be working fine so far. Now all that's left is to actually implement the logic on the controller side. All right. So now we're going to want to have a place where we can centrally reference our rate limits. So one way we can do that is go and add another package. This will be our models. And just call this our rate limit. I probably don't want to be calling everything the same word over and over. but I think for a small application, that's not that big of a deal. Now, it should be pretty clear that there's a little bit of an issue in our specifications, is that we never specified a persistent storage for rate limits. So if we were just to define some global variables and set the value there, anytime we ever restarted this application, the service, you would lose any kind of transient state. And that is clearly not what the user would expect. But we never actually specified that in our original acceptance criteria. So we go back here, and if we look at our acceptance criteria, which is, oh, we didn't commit this back. So if we go into our documentation, back here. So none of these actually specify persistent state. C6. So what we're going to want to say is administrative settings should be not permanent, persistent. Should be persistent. It seems silly to specify this, but it's important to reference this, because if we did not follow this requirement, that could lead to some unpredicted nasty behavior. So for instance, should we choose to make this a Kubernetes service or Docker service that frequently restarts, each restart will silently drop any global state that the application is currently running, which means also the rate limits, the number of times that the application has hit a given domain has been forgotten. And what that also means is that the application will silently fail to follow its duty, because if it restarts, if a user had hit the rate limit, the application restarts, the user sends more requests that should be limited. Well, if the limit has been reset, the user will have those go through and violate the requirement, requirement number 3, which is that we do not violate the rate limit policy that was previously set. So, but for now, for development purposes, we're just going to create a simple class, and we're going to store that in a global variable and worry about saving that elsewhere. Let's say class domain rates and stores rate limits for each domain. And we'll have a private global class variable, domain limits, and it will be a dictionary. Per domain. So we'll create a class method, say set class domain, and give it a limit. And because this isn't a controller, we're assuming that the controller has already done its checking. So this shouldn't do any kind of fancy logic. It's just set and retrieve values. Later, when we have a permanent store, this will actually start worrying about the logic behind accessing that permanent store. So just pass some values. Say cls.domain limits, domain equals limit. And while we're here, might as well define a get. So this domain limits domain. And this actually doesn't need a limit as an argument. For given domain. this will be retrieves limit for given domain. All right, that's just our very simple model. Eventually we'll use a more permanent backing store, but for now, that's that. So then the controller can import the model. So we'll do import source.cli. Let's see. Oh, not CLI. Models.rate limit. And we'll say rate limit. Domain rates dot set, and then we'll pass in 2 arguments, to domain and the limit. And that should be that. So now we have a way to set the value of the domain. Now what's going to happen is if we invoke this is going to start the application, set it, close down the application, and promptly lose whatever we set. But that's fine for now. The point of the command line is not to actually serve as the application, as to serve as an initial test bed and to make it to quickly develop a new feature, go in, play around with it, and then see if it's ready to be developed further as a web endpoint. And to finish this episode, we're going to look at getting the rate limits. So we're going to do def get rate limit. So I'm going to pass in domain and limit. And this is going to be fetches internal rate limit of the domain. And so then I'm going to given a parameter domain and the domain. And we're going to return the numerical limit in requests per hour. Models.rate limit, domain rates.get, domain. I think this might be fine, just on one line. And we're just going to return that value. So a lot of this appears to be redundant. So for instance, you might ask, okay, why do we need this class, which is simply just returning stuff, when we can probably do it in here? In fact, why are we doing this here when we can be doing this in the command line? So for one, this model is more of a stub. So once we have a permanent store of back in the data, this code will be focused on getting and retrieving the data. This will be focused on the logic of, okay, now that we've gotten the parameters, do we need to do any special logic? Do we need to interpret the parameters differently based on different situations? How do we check for different possible error scenarios? Stuff like that. The command line is just the feeding in the raw input into the controller. And when we start actually developing the web proxy, all it's going to do is just simply take in the same arguments that it gets as HTTP arguments and pass them into the controller the same way as the command line. So it will be very trivial to implement. So if we go in to our command line, we're just going to add another command. So rate limit get one. So just get the rate limit. Main, which is the string. And this is fetch the rate limit. And domain is the name of the domain. So I'm going to say the limit is equal to source dot controller dot rate limit dot get rate limits domain. Then what we're going to do is say print the limit is given by this value. In requests per hour. So then if we go and try, let's see if that gives us any errors. And it actually should give us an error. I'll see what it is. Exactly, key error. So we haven't specified the cases where we haven't set a domain. So we kind of need a default. So for our default, what we want to do is say port, is it os.environment? Yeah, os.environment. So we're going to want to do is say get an environment variable. We're going to say specify as default limit. And given this is now in per hour, so we're going to say we're going to allow 5 requests per minute. For example, in default limit. So given this environment variable, that's default limit, get the value that we set. Otherwise, just set it by default. Set the default to default to 5 per hour. So if we do this, and then since it's a dictionary, we can do get, and we can pass in the default limit. So now if we try that again, hopefully that'll work. So that's 300 per hour. Now, let's say we can say default limit to, oh, what's a good value? What about 1 per second? Yeah, it now reflects that new limit that we set. So let's just go quickly document that. Default limit for domain. And now we want to make sure, are there any other error conditions for our getter? So if we pass in no arguments, we should get an error automatically. Yeah, missing argument. It doesn't matter if we put in a number, it'll just be treated as a domain. The other thing is we can add one last quick one, domain string. And what we can do is also check if the domain has a limit set. So dot domain limits. So this will always return at least some value, but sometimes we might want to, for human readable input reasons, actually say, oh yeah, this is the limit, but it's the default limit. It's not because somebody said it, which may be very important for debugging potential issues down the line when somebody sets a value and that value is not being acknowledged. So what we can do is say, we're going to get rate limit. We can also say as rate limit domain string turns true if internal rate limit has been set for domain. And if we do this, and return, only if rate limit has been set. Error source models dot rate limit dot domain dot has domain. Now, our get, what we can do is also say has limit equals source dot controller dot rate limit dot has and then we can say if the limit has not been set, print out, say warning, limit for domain has not been set. And we probably don't need to reprint out the domain name. So now if we try this, we'll get a warning saying the limit has not been set. It's just getting a default value, which we already know this now, but coming back later, that may be helpful. Because it's very likely that a user can say, do something like say set www.example.com, and then the user references either a typo, say dub, or they just go to example.com or a subdomain that doesn't match www, and they might actually hit the same server, but because this isn't the exact same value that we set internally, it's not going to be using the value. It's not going to be using this value. It's going to be using the default value. And the user might initially be very confused as to why they're getting a different rate limit, particularly if we set it really low. And it's nice to have a way to say, okay, we did successfully identify that this domain is using a default environment, not the one that was previously set. So that wraps that up for this episode. And in the next episode, we'll be looking to making the models more persistent between runs.